So for this question, it's really important that you draw a proper diagram that works for the situation. Because if you draw an incorrect diagram, it's really hard for you to get the right answers. So a tower 42 meters high, so I'll start there. So that's 42 meters. Stands on top of the hill. Now you can really draw any orientation you like, but you really want to, in order to get the correct answers and utilize the different rules, you want to make sure it kind of lines up at the top of your mountain, like so. Okay, and then so the middle point kind of lies down all the way to the bottom. So now we read the next part. From a point some distance from the base of the hill, so a little bit, let's just say this point, angle of elevation to the top of the tower is 13.2. So top of the tower, I'm going to go aim for the middle. So that angle of elevation, I might move this 42 meters out the way. This side. Angle of elevation is 13.2 degrees. And the angle of elevation to the bottom of the tower, so over here. That angle is 8.3 degrees from the height of the hill. So as you can see, hopefully you understand that there's two triangles. There's this triangle we can work with, the bottom one, and then there's the big triangle as well as this, there is this third triangle over here as well that you can work with. So let's figure out what we need to find in order to answer the question. So find the height of the hill. The answer we're trying to find is this length. So I'll put a little H symbol there. So the height is what we're trying to find. We don't know really anything else. Well, first of all, I can figure out this angle here because this whole thing is 13.2 degrees, and then that one's 8.3. So I should be able to do 13.2, take 8.3 degrees, and find my answer for that angle. Which is 4.9 degrees. Another thing I can find is this angle. If I have a look at the big triangle and copy it down over here, this one is 90 degrees. That one's 13.2 degrees. So I should be able to find this by doing 180. Take 13.2, take 90 equals that angle. So that hopefully that comes naturally to you and you don't have to think much about it. Which equals 76.8. That's 76.8 degrees. And I can write that on my diagram as well. So now I know, as you can kind of see, I'll see if I can highlight it with my pen. I know this length, and then that angle, which is a complete pair, and then I also know this angle, and then what I should be able to find is this length over here, which is a pair as well. So I'm going to use my sine rule to figure that out. So my unknown goes at the top, my pair is sine 76.8, length goes at the top, and then sine of 4.9. So this is what I have to rearrange in order to find x. So I'm going to times sine 76.8 on both sides. So therefore x is 42 sine 76.8 divided by sine 4.9. I get 478.7 meters, so approximately. Or I could, on my next step, just use the exact value as well. Up to you, really. I always like to write the exact value. So I found my x. Okay. Now what I have is another pair. So I'm going to try to use different colors. So this is the complete pair. I've got my x and the 90 degrees. And then another pair is this one, h, and the 8.3 degrees as well. So now I can use sine formula again to figure this out. I'll try to use this different color for that one. So unknown goes at the top, h, and then my sine 8.3. My distance for x was approximately 478.7, so I might just use that for now. I could write all of it, up to you. So I'm just copying that down if you're wondering what I was doing. I'll leave that there maybe. And then divided by the sine of 90 degrees. So if I just rearrange that, I just got to get rid of the sine 8.3 and then chuck that in the calculator. So I get about 478.7 meters. So I might round it to 479 meters. So that should be the height of the hill. So you can include that there for height of the hill is 479 meters. And I'll just double check the answer so I can go through it. Oh. Question 5.